Good morning, everybody. Okay, so quick announcement. You have a quiz next week. So next Tuesday, there is a quiz. It's going to be, I guess, in this room, unfortunately, but that's the room we got. So there's going to be a written quiz in here next week. So I'll post an announcement later today indicating exactly which topics will be covered on the quiz. And I will post a sample quiz for you as well. So that'll all happen this afternoon as soon as I get home to my home office and get onto a real computer. I'll post information about the quiz. Right? So the quiz is, it's like, I mean, you get 50 minutes to write it, but most students finish early, the first quiz. So it's not, you should have ample time to do the quiz. Right? We haven't done that much in the course yet. Right, we've only basically been here for like 4 weeks, so there isn't that much to know. Right? And when you see the sample quiz, you'll realize that I don't ask you minutia, right? So I don't. You've got all these notebooks, but I'm not going to ask you to memorize like some sentence from some notebook somewhere that contains some obscure piece of information, right? I'm trying to assess whether or not you are keeping up in the course at this point. Right? Okay. Any questions about the quiz? All right, if you have academic accommodations, of course, you should write it with the exams office, right? So the exams office is aware of the quiz, and you're just going to write it with them instead of writing it here. Okay, so there's a second announcement. The variables notebook contains, we were working through the variables notebook. We got to this part here. All right, let me just... Okay, so this is the section where I stopped. So I stopped just before this section. This section's all wrong in the notebooks that you had access to begin with. I fixed the notebook over the summer, but I forgot to upload the correct notebook to GitHub, and so everything's all messed up now. So I fixed the notebook last night, and there is now an updated version of the notebook. You can just download the file and replace the corresponding notebook file in whatever directory your notebooks are in, and you'll have the corrected notebook. Right. Okay, so we were talking about variable assignment, right? So you make a variable in Bash, you can store a value in the variable, right? To get the value of the variable, you need to use the $sign to dereference the variable. We learned about expansions in a previous lecture. So the question is, can I store an expansion in a variable, right? So for example, can I do a brace expansion like this, right? And can I stash that result in a variable somewhere, right? And the answer is yes and no. Some expansions can be stored in the result of some expansions can be assigned to a variable, right? The result of other expansions cannot, right? So a bit strange. Right? So here are the expansions that we've seen so far in the course, right? We've seen them all, right? So here's a brace expansion. Right? So remember, inside braces, you've got a comma-separated list of strings, right? That produces a list of strings containing, each string contains one of the things inside of the braces, right? If you have a prefix, right, the prefix appears in every string. So that should give you the string, that should give you the list of strings, the good, space, the bad, space, the ugly, right? There's a brace expansion that uses a range. We know that's a file name expansion, right? So that should match all of the files that end in IPYNB, right? Those are your notebook files. Tilde expansion, so that expands to your home directory name, right? That's what we were looking at right now. That's parameter expansion, right? And we saw arithmetic expansion very briefly in a previous lecture. Right? So I would like to try to store these in a variable, right? So I'd like to store, for example, the list of strings generated by that in a variable, right? And it turns out that particular one doesn't work. So on the right-hand side of the assignment operator, right? The values on the right-hand side, they undergo some expansions, but not all, right? So they undergo tilde expansion, parameter expansion, command substitution, and arithmetic expansion. Oh, there's a command. Well, we'll look at command substitution in a second. Right? And so that means brace expansion and file name expansion are not performed on the right-hand side of the equal sign. Okay, so let's see what is the implication of that? Right? So here's one brace expansion. Right? Notice the question mark here. Right? Can I actually store this in the variable movie? Right? So can I store the string or the list of strings, the good, the bad, the ugly, inside the variable movie? Right? Can I store the years 2020, 2023, and so on up to 2029 in the variable years? Right? Can I store the name of all of my notebook files inside variable notebooks? So you try it out. Right? So here I'm just going to print out the value of movie, the value of years, and the value of notebooks. Right? And when you run that, you can see that you don't get the expansions. Right? What you get are the strings. You get the literal strings, the good, the bad, the ugly. Right? And you get the literal string brace 2020, blah, 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 blah. And you get the literal string star IPYNB. Right? So the brace expansions and the file name expansions are not performed when you do the assignment. Right? Now, what's super confusing about all of this is if you change the location of one of these double quotes. Right? So if I move that double quote to, say, here instead, right? So now what happens? Right? So there's my string. So I should expect the string Jupyter Notebook Files : space to be printed out. Right? And there's a variable now. Right? So there's a parameter expansion right there. Right? So the super confusing thing here is that when you run this script, you actually get all the file names now, right? Which is really weird, right? So you say, well, that's not right, right? You just told me that when I do the assignment, right, the value of notebooks does not actually contain the expanded file names, right? And that's true. The value of notebooks does not contain the expanded file names, right? Just move the double quote back, run it again, right? And you can see it does not include the expanded file names, right? So what's going on here, right, is that you've got a command, right? You don't have assignment now, right? So there's a command, echo, right? Echo sees one argument, which is a string. It sees a second argument, which is a parameter expansion. So now it performs the parameter expansion, right? What's the value of notebooks? It's star IPYNB. What does that expand to? It expands to all the file names in the current directory that end in IPYNB, right? And now you get the name of all the files, right? So it's super confusing. And the notebook, the way it was previously written, had it written this way. So it looked like the expansion worked, but that's not, in fact, what's happening, right? The expansion does not happen in this example. Right? So you cannot store the result of a brace or file name expansion in a variable. However, the other expansions, those all happen on the right-hand side of the assignment operator. Right? So if I perform a tilde expansion on the right-hand side of the assignment operator, that expansion actually happens. Home dir should contain the name of my home directory. There's a parameter expansion on the right-hand side of the assignment sign. Right? So the parameter expansion should happen. Right? So I should get this is space some string stored in the variable y. Right? That's command substitution. Right? So remember $single round parentheses, right? And then some command inside the round parentheses that runs the command inside the parentheses, takes the output, and that will store the result in the variable mu. Right? So we should get a cow saying sys220. There is arithmetic expansion. Right? So that arithmetic expansion occurs on the right-hand side of an assignment operator. So the sum should be 8. Right? And now when I print out these values, I should get my home directory, some string, this is some string, a cow, and the number 8. Right? And you do. Right? So some expansions happen. Most expansions happen. Brace expansion and file name expansion does not occur on the right-hand side of the assignment operator. Right? So if you want to store the result of an expansion, right, you have to remember that 2 of them won't be stored. Right? The brace expansion and the file name expansion are not stored. All right, so that's all that we need to say for now for assignment or for variables. Right, later on, we're going to learn about arrays, and arrays behave a little bit differently. So they have extra assignment operators that you can use, and you can do some other things with them as well. All right. Any questions about assignment? So the next topic that I want to talk about are strings, because everything in Bash is a string. Right? So it's kind of important that you know how to manipulate strings. Right? And so not surprisingly, there's a strings notebook. Okay, so this looks like it's a notebook about strings. If you actually go and look at the Bash manual, a lot of what I'm going to tell you actually falls under the category of parameter expansion. Right? So it actually falls under the category of working with variables, which is strange, but when you realize that all values in Bash are basically strings, then it's not so strange. Okay, so I'm going to warn you now, the syntax, if you think the syntax of Bash is weird now, you're going to think it's even weirder after this notebook, right? Because it's very strange. The string manipulation operations have a very unusual syntax. Okay, so number one, suppose you want the length of a string, right? Then the way you get the length of a string is with the syntax, dollar, brace. The braces have to be here in this example, in this case. Right? So dollar brace number, and then the name of the string variable, or the value of the string. Right? Right? So dollar sign, brace, number inside the braces. Okay, so if my string is the string sys220, then the number of characters in sys220 should be 7. Right? The way you get the 7 is with the dollar brace number notation. Right? So that's 7. Okay, you can get a substring from a string. Right? So to get the substring from a string, it's that is 1. That's the simplest notation there. Right? So dollar brace, and then either the string variable or the string itself, right? Colon offset. So offset is the offset is the starting index of the substring that you want. It goes to the end of the string. Right? So the indexes in Bash are 0-based. So if I have the string A through J, right, then the substring starting at index 0 going to the end of the string is just the original string itself. Right? So it's A through J. S:1 asks for the substring starting at index 1 going to the end of the string. So for most of you, this is going to be the confusing part because you're used to Python and Java. Right? So the substring, if you don't want to go to the end of the string, then you pass in 2 values, or you use 2 values separated by colons. Right? The first one is the offset again, so it's the starting index of the substring. Right? The second argument, though, is the length. Right? It is not the stopping index or 1 past the stopping index like it is in Bash, like it is in Java or like it is in a Python slice. Right? It's the length of the substring that you want. Right? So S:3:5 says start at index 3. So that's the D. Right? And then give me the substring consisting of 5 characters starting at the D. So E, F, G, H. Right? So you should get that. Right? 3:4 means start at the 3. Give me the substring. Start at index 3. Give me the substring of length 4. Right? 3:3 is start at index 3. Give me the substring with length 3. 1:1. That's how you get a single character out of a string. Right? So that gives you a single character. The character is, again, a string, right? So it's still a substring. And of course, if you do something :0, sorry, not 1:1, the :1 as the second argument, that's or as the second argument for the colon, right? That gives you the substring of length 1. You can get the substring of length 0 if you need it, I suppose, by passing in a 0. So run that, and you can double check the results, right? So that's the first one. right? Give me the substring starting at 0, including all the characters to the end of the string. Right? Substring starting at index 1, going to the end of the string. Right? Substring starting at index 2, going to the end of the string. Right? You just quickly check these. That has length 5, that has length 4, that has length 3. Right? So 5, 4, and 3. Right? There's the second character in the string. Right? And then that should be the empty string. So there is a blank line right there. Right? So there's the substring operators. Yeah.
Why does the second last one have 3 characters?
The second. This is the third last one. That's this one.
Oh.
The last one is blank, right? So there's a blank line there. Yeah. So like Python, the offset can be negative. So actually, the offset, I think the length can be negative as well. So the offset can be negative, which means you want, it treats it as the index starting from the back of the string. So if you do this, right, you have to insert a space before the negative sign. Right? If you don't insert this space, Bash gets confused. And I forget why it gets confused. Oh, yes, that's why it gets confused. It's because colon minus actually means something else that we're going to see later in the notebook. Right? So that space has to be here if you want to pass in a negative index for the starting index. Right? So s colon minus 1 means give me all the characters in the string starting from the last character. Minus 2 means give me all the characters in the string starting from the second last. And minus 3, give me all the characters in the string starting from the third last. Right, so here we should get j, ij, and hij. All right, if you give a negative length, then the length is treated as, in which case it is treated as an offset. Okay, then it's treated as an offset from the end of the string as well. So if I pass in a length of minus 1, so starting at index 0, so all the characters starting at index 0, right? A length of minus 1 means all characters starting from the first, going to, but not including the last, right? So now it's treated as an index, right? So colon 1, starting from the second character, going up to, but not including the second last. So all characters starting from the second, going to, but not including the second last. Right? And that one's not including the third last. Now notice that if your quote-unquote length is negative, right, you don't need the space in front of the minus sign. Why don't you need the space in front of the minus sign? Because colon minus is only special if it's the first colon that appears in that expression there. And so you get that result right there. I don't remember if you can put the space in or not, so hang on, let's just try it. Okay, so it still works. So if you want to be safe about it and you're using a negative value, just stick a space in, right? And all your problems will go away. All right, so there are some expansions that remove parts of a string. So you can remove the leading part of the string and you can remove the ending part of a string. And the criteria for what gets removed is done using what's called a pattern match. Right, now, fortunately, the pattern match is exactly what I told you when we did file name expansions. Right? So star means match any string. Right? Question mark means match any character. The square brackets means match any character inside the square brackets. Right? And so on and so on and so forth. So there's 2 variations for removing the leading part of the string. Right? So $, the string, or a variable containing the string. Right? Hashtag pattern. That expands to the string form by removing the shortest part of the string that matches the pattern. Right? If you want to remove the longest part of the string that matches the pattern, then you use 2 hashtags. Right? So shortest part that matches the pattern, longest part of the string that matches the pattern. So there's an example. So what you have to remember here is that when you do the pattern match, right? So when you write star dot here, it means the same thing as in file name expansion, but it doesn't apply to the files in your directory. It applies to that string now, right? So it's not applying to the files in the directory, it's applying to this string. Right? So I have the string file.text, right? I would like to remove the file dot, right? So I want to remove the file dot. So in other words, I want to remove the part of the string, the leading part of the string that matches anything, right? So this could be anything here, right? Followed by a dot, right? So remove anything followed by a dot. So that way it works if I change file to something else, right? So there's your string that you want to manipulate, right? One hashtag, so remove the shortest part of the string at the front. That matches star dot, right? So anything followed by a period. Right? So the shortest part of the string that matches anything followed by a period. Right? So you look at this string, and so that's the shortest part of the string that matches anything followed by a period. Right? If you use hashtag hashtag, that's the longest part of the string that matches anything followed by a period. Right? So again, that's the same as the shortest part. Right, so both of those expansions yield the same result. If you change the file name to something like that, right, now you get a different result. Right? So one hashtag, shortest part of the string, that matches anything followed by a period. Right? So the shortest part of the string that matches anything followed by a period is that. Right? And so that removes the file dot and leaves you with the text.zip. If you really want to get the extension, which is usually the last part of the string that starts with a period, right? Then that's two hashtags star dot. Right? So longest part of the string that matches anything followed by a period. So the longest part of the string that matches anything followed by a period is that. Right? So here we should get text, text.zip, and zip. Right? And you do. Right? So if you want to get the extension from a file, the correct way to do it is, well, one way to do it is that way, right there. If you incorrectly use the single hashtag, then that typically leaves you with extra extensions if the file name happens to contain multiple extensions. Okay, so inside a script, it's very occasionally useful to get the name of the script, right? Now, remember, you can get the command that was used to call the script because that value is stored in the parameter 0, right? So $0 contains the path name for how the script was called. So if you want to get just the name of the script, right? So in other words, I want to strip off everything except the script name, right? You can use hashtag to do that, right? Okay, so inside my script called script name, okay, so how is the script invoked? Well, the script was invoked. How the script was invoked is stored in the parameter 0. Now, there's an example of calling the script from my current directory, right? I want to get just this part here, right? So to get just that part there, I want to strip off everything in front of the string, right? Or everything in front of the script name ending at the slash, right? So I would like to match or remove the longest part of the string that contains anything followed by a slash. So longest part of the string, right? The pattern is anything followed by a slash. So if I run that, right, it prints out the value of $0, right? So $0 was all of that, right? How the script was run, right? The name of the script is just script name.sh, right? So that's one way to do it. It turns out that this is, how common is it? It's not super common to try to figure out the name of a script, right? There is a command though that will tell you, right, what the name of a script actually is. So the command base name will give you the name of a script given a path to the script, right? Or sorry, the name of a file given the path name to a file. It doesn't have to be a script. Right, so base name works as well. Base name exists as a command already. All right, so if you can remove the leading part of a string that matches a pattern, right, it makes sense that you can also remove the trailing part of a string that matches a pattern, right? So all of this is exactly the same, except now it removes the part at the end, right? So to remove the part at the end, it's the %, right? 1% means remove the shortest part at the end of the string that matches a pattern. Right? 2% signs means remove the longest part of the string that matches a pattern. Right? The pattern match again is the same as before. Right? Okay, so before I got the extension, right? So now I would like to get the name of the file itself, right? Without the extension. So that's called the base name of a file. So how do I get just the file, right? Or just the name of the script? Well, I'd like to remove everything at the end of the string that matches dot something, right? The txt could be some other extension, right? It could be .zip or whatever, .pdf or something like that, right? So the pattern is .star now, right? Starts with a period followed by anything, right? Remove the shortest part at the end of the string that matches a period followed by anything. So the shortest part of the string is that, right? That matches that pattern. Right? The longest part of the string, if you want to remove %sign means remove the longest part of the string that matches the pattern at the end. Right? So in this case, they're both the same. If you have multiple extensions, now the answer is different. Right? So shortest part at the end that matches .star. Right? So the shortest part at the end that matches .star is the .zip. Right? So in this case, you end up with file.txt. Right? Longest part that matches .star, so dot followed by anything. Right? So the longest part is that. Right? And if you run the script, right, you get file.txt, and file. Right? So in this case, they give you the same answer. Right? If you have multiple extensions or something in your file name, right, then they give you, now you get a different answer. All right, so replacing a substring. So again, you can replace a substring that matches some pattern, right? Oh, so when I talk about pattern here, right, the pattern doesn't have to contain the symbols dot and star and things like that, right? So the pattern can be any text. Right? So in this example here, if you happen to know that the extension is txt, right, you don't have to use this dot star, right? You can say, look, just remove everything that ends in .txt, right? And you get the same answer, right? Similarly, here, right, if you happen to know that it ends in, in this case, it doesn't work, right? So in this case, if you really wanted to remove the .text.zip, right, then either you have to know that it ends in .text.zip, right, or now you have to use the pattern. Right? If I just use .zip, then it's only going to remove that, right? And if I use .text, it won't remove anything because it's not at the end of the string. Right? So by pattern, the pattern can just be regular old characters, right? And it will match whatever part of the string. It will remove whatever part of the string. The pattern will match if it matches those characters exactly. Right? So you don't have to use the special character, the wildcard characters here. If you want to replace part of a string that matches a pattern, right? Now it's the / and the /. Right? So variable that holds a string, / pattern slash replacement string that replaces the first substring, sorry, that matches that pattern, right? And the text that is used to replace it is whatever that happens to be there, right? So the string REPL replaces anything that replaces the first thing that matches that pattern, right? Slash slash in front of the pattern means replace all substrings that match that pattern. That match that pattern with that string, right? Notice that the difference here, so they have a significantly different meaning, but the difference in the command is only a single slash, right? So this is another reason why debugging bash scripts is very hard to do, right? Because you can be off by just a single character, and it means something completely different. Also notice that it's not double slash slash here, right? It's still a single slash at the end. Okay, so here's my string sparring with a purple porpoise, so lots of P's, right? I would like to replace the first P, right? So /P, replace the first P with a T, right? So now you're going to get starring with a purple porpoise. Replace all P's with a T, right? And now you get starring with a turtle tortoise. Right. Oh, yes, right. I'm also printing out the original string. So all of these manipulations that I'm talking about, they don't change the original string. Right? What they do is they give you a new string that contains the manipulated value. Right? So S never changes in this example. Right? It's always the original string here, right? And here it's and again it's the original string here, right? So these expansions don't modify the original string, right? They produce a new string containing the modified string. Why is this repeated again? It's the same thing, right? Echo. It is, okay. So this one you can delete. Oh, so the replacement string can be empty. So that lets you delete characters that match a pattern in a string, right? So if the replacement character here is nothing, that removes the first P, right? So you get starring with a purple porpoise. That removes all P's. So you get starring with a purple orpus or whatever, however you pronounce that, right? And again, the original string itself is left unchanged. Right? So S never changes in these examples. Occasionally, it's convenient, it's useful to convert case, right? So convert from uppercase to lowercase or lowercase to uppercase, right? That's what the comma is for, right? So the comma followed by a pattern expands to the string formed by converting the first character of str to lowercase. Right? Now, there's an extra part to this though, right? So str comma followed by some pattern tries to convert the first character of the string to lowercase. However, the conversion only occurs if the first character of string matches the pattern, right? Otherwise nothing happens, right? The expansion results in the original string. Okay, so here's my string: big A, big A, big B, big A, B, C. Right? I want to convert the A to lowercase. Right? So that's string comma. Right? Now the pattern needs to match the character that I want to change. Right? So the A does in fact match the A. Right? So 1 should print out little a, b, c. Right? So 1 is a, b, c. Okay. Second one. Right? So I would like to convert the first character of the string to lowercase, right? As long as the first character matches ABC, right? That doesn't the first character is not ABC, right? The first character is an A. So this one should not work, right? It should give you back the original all uppercase string, and it does. Ugh. All right, so remember that this thing here is supposed to be a pattern of some kind, right? That's the pattern A. That's the pattern ABC, so it's a string of length 3. Right. Don't forget you have the square bracket notation that you can use as well, right? In a file name expansion or pattern match. Right. So the square brackets ABC means as long as the first character is one of A, B, or C. Right? Is the first character one of A, B, or C? The answer is yes, right? It is the uppercase A. So 3 should cause the first character to become a lowercase a, and it does. Right? If you always want to replace the first character with its lowercase version, right, you can use the question mark because question mark matches anything, or you can leave out the pattern altogether, right? In which case the first character always gets converted. Right? And so both of those work as well. Again, the original string is not modified, right? So if you were to print out the value $str, right, it would always be all caps ABC. If you want to go the other way, if you want to go to uppercase, then instead of the comma, it's the caret, right? So it's the caret. Right? And again, these are all these same examples. Right? So X, Y, Z, all lowercase. Right? Replace the first character with its uppercase version as long as the first character is an X. Replace the first character with its uppercase version as long as the first character is equal to X, Y, Z, which is never true. Right? Replace the first character with its uppercase version as long as the first character is either U, V, or X. Right? Always replace the first character with its uppercase version, and if there's nothing, then it's always replace the first character with its uppercase version. Right? Now, not surprisingly, right, we saw like hashtag, %. There's also a comma, and a caret. Right? So those try to replace, attempt to convert each character of the string by matching each individual character to the pattern. Right? It goes character by character, trying to convert. Yes, question?
Sorry, what's the difference if I have a question mark or if I just have a blank?
There's effectively no difference. The question mark means match any character. The blank or the nothing, right? It's not the blank, right? It's nothing. Nothing also means match any character or always perform the conversion. Yeah. So comma means process each character of the string, right? Applying the matching rule to each character, right? Same with caret. So here we have all uppercase ABC X, Y, Z. Right? There I've got the comma. So attempt to replace every character. Attempt to convert every character to lowercase as long as the character matches the B. Right? So that should give you A, lowercase b, and then all X, Y, Z. C, X, Y, Z. Right? So it only converts the B. Number 2. Try to convert every character to lowercase as long as the character matches A, B, C, X, Y, Z. Right? And so no character matches the string of length 6, right? So this does nothing, right? Leaves the original, gives you back the original string, right? Attempt to convert every character to lowercase as long as the character matches, so that is uppercase A, uppercase B, or uppercase C. Right? And so the first 3 get converted, right? Again, the question mark works, right? And specifying nothing also works. So question mark matches anything, so it always does the conversion, right? If there's nothing there, it always does the conversion, right? So both of these result in, the entire giving back the string where the characters are all the lowercase versions of the original string. Oh, this is fun. All right. So remember I told you that if you use a variable in bash and that variable doesn't exist, you end up getting bash creates the variable, gives you the empty string for that variable. Right? The same is true if you access a positional parameter and the command line argument corresponding to that positional parameter was never specified. Right? So if your script expects 3 command line arguments and you only give it 2, right, then $3 is the empty string. Right? I don't remember if it's empty or unset. There's a difference. Okay, so to deal with these cases, right, so if you don't want to deal with, if you're expecting an argument and it's not there, right, you might consider giving that argument a default value instead. And so there are a variety of ways to do this. Right? Don't commit this to memory, by the way. Right? I'm never going to ask you what these mean on a quiz or an exam. Right? Or if you get asked about it, you get a reference sheet explaining, telling you what these all do. Right? So I'm just going to explain what these things are useful for. All right, so we've got the first one here. Right? We've got some string variable, str. Then we've got minus, and then we've got another string, right? Some word. Okay, so if the variable str is unset, right? In other words, if it does not exist at this point in time, right? Then the result of all of this, right, is whatever string word happens to be. Right? So if str does not exist, the expansion ends up producing the string word, right? Whatever the value of word is. Right? And so that lets you handle the case where something's not set, right? And you want to give it a default value anyway. Right? Okay, so if string is empty instead of being unset, right? So unset means does not exist, yes, does not exist, right? Empty means the string does not have a value, or is so the variable exists but is empty, doesn't have a value, right? Then the result is the empty string, right? So string doesn't exist, you get word. String exists but it's empty, you get back the empty string. If string is not empty, then you get back the original string str. Right? So if string exists is not empty, then you just get the string. Right? There's colon minus. Right? So notice that this is why when you're specifying, when you're accessing a substring, right? If you use a negative index, you need a space. It's because if you don't put the space in, bash thinks you're trying to do this. Right? It thinks you're trying to deal with an unset or empty variable. Right? Okay, so the first one behaves differently if string is unset or if it's empty. This one behaves the same way if string is empty or unset. Right? So if string does not exist or is the empty string, then you end up getting whatever the value of word is. Right, in both cases. If string exists, then you get back, if string exists, yes, if string exists, then you get, and is not empty, you end up getting back the original string. Right? So this is the useful one. Right? For giving a default value to a variable that might be empty or might not exist. Right? That lets you automatically give it a value. Right? I'm going to let you look at the other ones to find out exactly what they do. So you should play around with the other ones to see how they differ. Right? The difference between all of them is subtle. Right? Well, at least for the first 4. Right? So you should play around with these and see exactly what they do. Right? But that is useful, especially when you're dealing with the command line arguments. And if someone doesn't specify a command line argument, you want to give it a value. All right, so that's it for today. We'll pick this up on Friday.